Hello everyone, welcome back to the Zeus Developer channel. Today we're going over AWS 101, looking at the components that make up AWS networking. So I did this article, a blog on Dev.to a couple of days back. That's the blog we're going to go through, and then we're going to demonstrate how we're going to create those networking components. And at the end, we're going to run a simple web server, to see that everything is working fine. All right, so before we do that, if you don't have a AWS account or the CLI installed, you need to do that. There's a link here. This link is also in the description of the video. So you need this CLI installed on your system. So the link to this article is also in the description of the video, so you could look at it as well. So I have the CLI installed, have my AWS account, have logged into that, so I'm set to go. So at the top of the chain we have the VPC. So what's the VPC? Yeah, your VPC is how AWS creates your own portion of their cloud infrastructure, for you to run all your stuff, right? So you need a VPC to start with. Now, when you create an AWS account, it comes with a default VPC, but you're not supposed to use that. So you need to create your custom VPC. So everything starts from your VPC. So let's copy the command, and then we're going to run them and provision this component. That's basically what we're doing. We're demonstrating the stuff talked about in this blog. So let me increase this a little. Oh, yep. So let's create a VPC and enable fancy host names. So we'll copy this command, and then we're going to run it. So let me quickly explain this. AWS CLI commands are very simple. Of course, at the top you have AWS, and then EC2, because all of these components, are of the EC2 resource. Because at the end of the day, that's what you're trying to do, right? Create a provision EC2 instances, for your application, and then the action you want to perform. Right? In this case, create VPC. That's the action you want to perform. And then you have options and parameters. In this case now, to create a VPC, you will need a CIDR block. If you don't understand this, there's also a link there, where I talk about to a post where I talk about CIDR blocks. So you can read that to understand how to shoot the CIDR blocks. So we're just going to hit create. All right, VPC is created. We're going to copy the VPC ID, which is right here. Copy it and hit Q to close this. I'm going to paste this here because we will need it very soon. So what's the next thing? To take note of the VPC ID we have, and then we're going to now enable fancy host names. So copy this command to somewhere we can construct it. All right, so fancy host names. These host names, it's how, when you create a VPC, it doesn't just come with a public IP, but some DNS host name, so that you can, if you don't have a domain connected to your instance, you can send this out, and then they can access your server with the host names instead of an IP. All right, so this host name, same thing, is going to need the VPC ID. So we're going to copy this ID here and paste it here. Oops. All right, so copy this command, open our terminal, paste it, hit it. All right, we should be good. What's next? That's what we're doing basically. Go through the post and just provision the resources. So next we have access control list, or NACL. So NACL is a stateless network resource that controls traffic to flow resources in a VPC from the subnet level. Right, it allows or denies traffic. So every VPC needs at least a NACL, hence on creation of new VPC, AWS automatically creates a NACL attached to the VPC, meaning we don't even need to touch it. So as we created this VPC, AWS automatically creates a NACL for us and attach it to the VPC. So we're fine with this, but just know that this is also there. You could control traffic from this level. Then we have Internet Gateway. Internet Gateway is truly a VPC's gateway to the internet. Yep. So for instance here, say we have a website domicile in an EC2 instance with a public facing IP. All right. So how would someone be able to browse that website, all right, from the internet? It's through the internet gateway. It's really a router, connected to your subnet. So resources on that subnet have internet access. So we're going to create one, since we created a custom VPC. So this is the command here. Created. Always remember to copy your IDs when you create resources, because you will need it. Press Q. Let's go to our note-taking tab and paste this here. What's next? To take note of the ID, of course we did. Now we're going to attach it to the VPC. So we're going to paste that command here and construct it properly before we run it. So this command now needs two parameters. All right, we are attaching the gateway we just created to our VPC. So we need the gateway's ID, which is here. We're going to copy it here, come here to paste it. Then VPC ID, which is here. Paste this. We should be good. Come here. Let's run it. Good. Don't worry, when you don't see an output like this, things are working well. So next we have route table. So route table is basically a collection of network routes, that determine the flow of internal and external traffic in your VPC. So a route table is attached to your subnet, and a route table is how you even use your this internet gateway that you created. All right, your internet gateway, your route table would have at least a route that utilizes that internet gateway. That's how that subnet that the route table is connected to gets internet access. The subnet, meaning that resources on that subnet gets internet access. All right. Since a VPC has multiple routes, each route table associates with at least a subnet. Okay, this is what I just explained. All right. We said a route table is a collection of routes here, so we need to define a route for internet access, egress and ingress. This route table would use the IGW, okay, that's internet gateway, as its target. So this is a command here to create a route table. Oh no, we're not creating a route table, mind you. Of course, AWS does a lot of things for us. AWS has created a route table for us automatically with the creation of the new VPC. So all we need to do is to create a route, because remember, a route table is a collection of routes. So we're going to create add a route to that route table. So let's copy this command to create a route. Now, if you look at this command there, it says route table ID. Right. So we need to go get our route table ID. All right. So to get the route table ID, list all routes. All right. Okay. So we'll copy this command because we need the route table ID, and then we're going to create a route on that route table. So first of all, we need to get the route table ID. So we would list all route table, and then look for the particular one that has our CIDR block. Look at it. Remember the CIDR block we use for the VPC, right? So let's look at the route table ID. Look at it here. Route table ID. It's also here. So let's copy this. Press Q here. Alright, so we'll copy the route table ID, and then we're going to paste it here. Then the next thing, destination CIDR block, and then a gateway ID. Gateway ID, it's where's our gateway ID here? So destination CIDR block, it's actually where you're allowing traffic to come from. So when you see a /0, it means the entire internet, right? So you could put your IP address here, your own machine IP. That would mean it's only you that can access resources in this in this subnet. So if you see a /0, that means anyone on the internet. So this is probably constructed, I believe. So let's go run it, paste, and go. All right, created a route table. Press Q here. Created a route rather. So what next? Subnets. So think of subnet as a way of splitting your VPC into bits. All right, the subnet is how your VPC divides itself, to different availability zone to hold different applications and therefore redundancy. So we're going to create a subnet. There's a command here. Let's copy it, and we're going to construct it because it needs some parameters, or at least a parameter. So look at it here. Create subnet. It requires CIDR block and then VPC ID. CIDR block, it's so our VPC has a CIDR block, right? And then you're going to also give your subnets you create CIDR blocks. So let's do the same here. Let's give it the same CIDR block here. This means that this is the only subnet we're going to have in this VPC, because it's taking up all the addresses, right? That VPC provisions. So what is going to also require the VPC you're going to create this subnet in. So let's go copy our VPC ID, paste it here. So remember, if you intend to create more subnets, you need to adjust this, and then I still recommend you go look at that other post in the description to understand all about CIDR blocks and then dividing your IP range, over with your subnets. So that's properly constructed, I believe. Let's hit it. Subnet created. Copy your subnet ID. Look at it here. Press Q here. Let's go back. Paste. So we can delete the commands and just leave the IDs, just in case we need them again. What else? Enable public IP generation for your subnet. So we're going to modify the subnet we just created and enable the official, all right, so that the instances you create in this subnet would have a public IP. All right, so let's copy this and construct it properly. So it requires what? Subnet ID and then this flag. So our subnet ID is here. We're going to paste it here. All right, copy the entire thing. And let's run it. Good. AWS automatically associate this subnet to the NACL guild. Remember, NACL was created for us, so any subnet you create, automatically AWS will associate it to that NACL that was provisioned at the instance of a new VPC. So a subnet that wants internet access should have a route table in it. It should have a route in its route table pointing to the internet gateway. Meaning, now your subnet needs to be associated with a route table. But then that doesn't just give internet access. But that route table should have at least a route. Should have a route, right, that utilizes the internet gateway. That's how that subnet is said to be a public subnet. Now next we have security group. Security group, it's a stateful firewall at the instance level, right? So if NACL, it's a firewall at the subnet level, so it covers all the resources it creates, in that subnet. Now this is granular. Security group is granular, meaning that the firewall is on the instance you create. So you could what he does, it's you by default no port is accessible until you open it. All right. So for your EC2 instances, you have to open any port that you want. All right. So every other port is closed by default. So any port you want to use, you have to open it by yourself, and then allow traffic to that instance through that port. So we're going to create a security group. So let's say we want to create a rule for traffic for port 80. All right, port 80 is a HTTP traffic. That's the non-secure version. The secure version, it's port 443. So let's create this. Let's copy this and construct it. I should be cutting the command, right, and not copy. So the action here is create security group. It requires VPC ID, it requires group name, and then description. All right, let's get our VPC ID, paste. Please remember to copy your IDs. Copy Q, let's go back. Paste this. What's next? All right, now they add a rule to open. So security group will carry rules, different rules, for the different ports that you want to open. So we've just created a security group. We've not opened any port. Now this is a command to open port 80. Let's paste it and construct it. So authorize security group ingress, right? It requires group ID, the protocol, the port, and CIDR block. All right, group ID. This is a group ID, security group ID. That's what it's referring to here. Protocol is TCP. The port we want to open is 80, and the CIDR is the source. Where do you want to allow traffic from? Of course, /0 here means the entire internet should be able to access resources on this port. Right, so if you change this to IP, it means that you're the only one that want to be able to access this instance. All right, so this is good. We're going to just run it. Copy, cut. Do we need this? I don't know, but we could play we need it. No need to copy anything here. Q, let's go back. In fact, without going back there, we'll create another rule because we need SSH. SSH is on port 22, so we need to open SSH port in this security group. So just press the up arrow on your keyboard, to get back the previous command, or you could paste it again. Just come here and change the port number to 22. So we're opening port 22, for SSH access. Enter here, and we have port 22 open. Q, let's go back. All right, so yeah, this is what we just did. So next we have network interface. Elastic Network Interface, or ENI, is the virtual network adapter that lets resources between the VPC connect with each other and with the internet. All right. So your network interface is attached to your VPC. The way I think of it, that's that's what connects your instance to all other network resources. All right. Now, network interfaces are created in a subnet. So when you attach, when you create your instances in a subnet, automatically AWS will create a network interface for you, all right, using the subnet that you specify and the security group that you specify for that instance. All right, so meaning that we don't need to create one, but then you can create your own and then attach it to your instance that you want. But we don't need to do that because as soon as when you're creating a VPC, so when you're creating a new EC2 instance, AWS will create this for you using the subnet and then the security group that you specify. All right, so look at the flow here. So from the network interface, you have the subnet, and then the subnet is connected to a route associated to a route table. That route table has a route as internet access. All right, so next we have NAT gateway. So for every route table, there is a default local route for resources within the VPC to communicate. Yes. Now we said AWS automatically provisions a route table, right, on the instance of a new VPC. So it also automatically creates a route, a single route on that route table. All right, it's a local route table for resources in that VPC to connect, to talk to each other, but not with the public internet. All right, so meaning that that's private communication. So, but what if an EC2 instance which isn't public needs internet to download stuffs? All right. So if you now create EC2 instance, all right, pointing to that route table, it's fine. They can talk to each other, but how would it be able to? It can't access internet. It can't download stuff from the internet. Maybe to update the software packages. So if you need to do that, that's where a NAT gateway comes in. Right. So a NAT gateway allows instances in a private subnet to connect to the public internet. So we're going to we don't even need to create a NAT gateway really because we don't have a private subnet. Do you understand? We just have a single subnet and then which is public because it has internet gateway association. So if you have a private subnet and then you want resources in that private subnet to be able to access internet, like it's one directional, it's one way, right? That's when you will need a NAT gateway. But in this case, we don't because we don't have a private subnet. So I guess we'll just go to creating EC2. All right. So this is not an exhaustive list of your AWS network component, but yeah, these are the basic ones you need. So to finalize, let's create an EC2 instance utilizing the network resources we just created and configured, and let's hope that things work fine. So, but then to do that, we also need an SSH secret key or key pair to be able to log into the instance. So this is for access only, yeah. So it's you create a key pair, you give it a name, you can attach it to any EC2 instance you create, so that you can now use this key, to SSH into that instance that you would create. Now, this part is very important. We're going to copy this from where they said begin, from the dash from this quote, in fact, to this. So we're going to just copy from this to this. This is tricky. All right. So I'm going to press Q here to end this, but I'm going to now make sure I construct this properly, in my code editor. So I'm going to open VS Code here to do this. I'll paste this. So you will see \n, okay, indicating character return. So I'm going to look for all the \n and remove them. There are other ways to do this, but I think this is simple. All right, so I guess my key is fine now. So I'm just going to cut this, go back here, and then use nano to just create it. What are we going to call it? We're going to call it the same thing. Doesn't matter anyway. But just make sure it has a .pem fancy SSH .pem extension. All right. So I'm going to paste this. Quitting. So we have. Let's clear everything here and then check it. Cart fancy. Good. So we have our SSH created. SSH key rather. Okay. What next are we doing? Now it's time to create the instance. It's a long one, so let's look at it. I'll copy it and paste it here. All right, this is a single command, right? Don't mind that it's multiple line. So if you have a command that looks long, you could use a backward slash, to break your command into multiple lines for readability. All right, so this is the action we're performing, and these are the parameters. So we have image ID, instance type, subnet ID, group ID, the key pair, and then a flag here to say this EC2 instance should be associated to public IP address. All right, so this here means basically the OS that you want to install. So I've gone to copy this before now. This is actually AWS Linux 2, right? So that's where it's going to install in the machine that you're going to provision. All right, then the T2 micro, this is just a categorization for memory and CPU. This is just 1 gig of memory and 1 gig of 1 gig CPU. 1 CPU and then 1 gig memory. Subnet ID, of course, we're going to put the subnet ID that we have here. So that this is the subnet we're going to put this EC2 under, and it's the only one we have here. Group ID is this guy here. All right. So what did we call our? There's no blog, right? We just said fancy SSH. The name, please, not the entire file name, just the name. So you don't need to put .pem here. Fancy. Please let me go and confirm. Exactly, fancy-SSH. That's the name. Wait, was that a name? Oh my god, I'm not even sure again. Oh, sorry, look at it here. Fancy block SSH. That was the name we give it. So please, you have to make sure is this name here. So this is correct. And then we're going to have this flag here to say it should have a public IP address. So this is good. We're going to now run it. Hopefully everything works well. How does it look like? My command is broken. Okay, I'm going to hit enter. Voila, our EC2 instance is created. So look at it here. My ID, very important. There's a lot going on here. All right. So you will need the public ID, the public IP rather, or the host name, which you're not going to see yet until you come back to check again, right? On the first output, you won't see it. But look at what's going to happen. I'm going to press Q here, and then we're going to now check this new instance we've created, to copy the public IP or the host name. So the command is EC2 describe instances, and then it's going to need the instance ID that we copied. I'm going to paste this in. Of course, I'm going to remove some parts, this part here. You understand this? So this is like checking the details of this instance that we created. This is the command here. So it's going to print what you just printed before now, but this one will include the public IP and then the host name as well. So I'm going to hit this. All right. So look at it here. This is our public IP, and then this is the fancy host name that we enabled right on the VPC. Alright, so this is my public IP, and I think I'm good with this. So let's go see what's next here. What do we need to do? Okay, this is explaining the parameters here. So I've copied our public IP. Yeah, this is how we're able to get the instance side, the public IP. Alright, let's SSH into our machine and install a web server on that our instance. It's a simple web server called HTTPD, for Amazon Linux. So let's copy this command. This is the SSH command, by the way. It's not an Amazon CLI command. Let's paste it here and then look at it. So this is how you SSH into your machine. SSH here, here it's the key file. All right. So you indicate the location and the file name to the key file here, and then the user at the IP address, the public IP. So we're going to put our public IP here. So the EC2 here, EC2 user means it's the user of that AWS created for us for that your new machine. All right, it has the root user and then it has EC2 user. So we're going to log in as this user. All right, and then we're going to also indicate the key file here, the private key file. So what's the name we gave it? We gave it fancy SSH, fancy dash SSH. Yep, .pem, that was the file. It's in the same directory where we're going to run this command, so it's fine. You understand what that means? Yeah. We're going to copy it. Oh. Fancy, not funny. All right. Protection, private. Okay. So they advise you to change the permission for this file. So we're going to quickly do that. Change the perm to I think 400. Yeah, 400 or 600 is fine. Yep. So I think now it will work. Yeah, we're into our machine now. Don't believe me? Don't worry. Now we can install our server. Okay, so just do what are we doing? Yum. We're using Yum. So install HTTPD. Y, enter, and then we have a simple server, but we need to start it. So systemctl start HTTPD. Started. Let's check the status. Oh, it failed to start. And I said started. Can you imagine? You know what it needed? It does not have permission. Does not have permission. Now it does. Sudo please. Alright, what did it say here? Ryan. So our server, web server is running, right? Let's go test it out. So we've done all of it. We've installed this, we've started it, and we want to check the status that it's running. So if we go to our public IP, we should see it works, all right? Because the server comes with a default web page that shows this text. So what's our IP again? Here. Let's copy it, paste it, go. Yeah, it works. So guys, that's it. Everything is working perfectly well. So we've created a custom VPC, all right, and all the other network components that a VPC needs, for an EC2 instance to run. I'll install a simple web application, a web server rather, and see that everything is working smoothly. So thank you guys. Hope you enjoyed the video. Please don't forget to like and subscribe, and I'll see you in the next one. Bye.